So in this video I'm going to integrate the square root of x squared plus 9 with regards to x. Now I've done two previous videos on this integral, all with different techniques, and this is the third variation of this integral. So here I'm going to note this down as my variation number 3. Now the first two will be in the link below. You'll see I did a trig sub and a hyperbolic substitution. This one here is going to be similar to those two but with a slightly different ending. So here's my variation on this one this time. So my trig sub here for my x, I'm going to go x equals sinh theta. And as I want to get something to multiply by 9, when I square it, I need a constant to multiply this by to get 9 when it's squared. So I'm going to plug in a 3. So then when I get x squared, I get 9 sinh squared theta. Okay, so now usual when you're doing substitution, you need to find your derivative of your substitution. So the derivative of x will be dx, and then the derivative of this will be 3 cosh theta. So that's where we are so far. So now we're ready to plug this into our theta variable. So now our integral is the square root of x squared, which is 9 sinh squared theta, and then plus 9. So that's all inside my radical, and then my dx is 3 cosh theta, and as it's the derivative I want d theta. So now we're writing here 3 cosh theta d theta. So now all with respect to theta, there's no x in here. Okay, so now to simplify this off, the 3 can come out the front. So I've got my 3 there. And then here I can substitute a 9 out of this. So if I do 9 times sinh squared theta plus 1 and then take the square root of that, I will then have another 3. So 3 times sinh squared theta plus 1. So that's the equivalent to that. And then here I've just got cosh theta. Okay, and then d theta. Okay. Now the 3, we can see we can bring that out the front as well and multiply that 3 together. And then here we've got sinh squared theta plus 1. Well, there's a trig substitution we can do with that. Sinh squared theta plus 1, that's just cosh squared theta. And then if I square root that, I'm just going to be left with cosh theta. So let's take care of that. So now I've got 9 times the integral of cosh theta times cosh theta d theta. Okay, now here's where we got a different variation on how we're going to do this integral. Instead of going cosh squared theta, I'm going to do my product to sum formula for my hyperbolic functions. So the product to sum formula, so let's write this down on here. So product to sum formula. So there we've got cosh times cosh. So the identity for that is cosh of x times cosh of y. That equals 1/2 times cosh of x plus y plus cosh of x minus y. So here we've got two cosh functions. They're both theta, so I can plug in a theta for this one. So therefore I've got equals 1/2 of cosh of, well, x and y, they're both theta. So I've got theta plus theta, which is 2 theta. And then here I've got plus cosh of theta minus theta. So now I've got cosh of 0. Okay, so I've got half cosh 2 theta plus cosh 0, all multiplied by half. So cosh of 0, well, that's a value already, so there's no actual theta involved in that. So cosh of 0, that equals 1. So therefore we're all ready straight to cancel that out and just write 1. So now our integral can take this form here now. So I've got 9 times 1/2 of cosh of 2 theta plus 1, and then that's still d theta. We're still in terms of theta. So now the half can come out the front, and I've just got an integral now with cosh 2 theta plus 1, which is a nice simple integral for us to take care of. So 9 over 2 cosh of 2 theta plus 1 d theta. Okay, well, integrating this, they're nice integrals to do, nice and straightforward, all standard integrals. So now I've got 9 over 2. Now let's put the constant multiple with each term as I integrate it. So cosh of 2 theta, well, that's going to give me sinh of 2 theta, and then by the chain rule I need to divide by 2. So now I've got sinh of 2 theta, and then divide that by 2. If I do that, I can just change this to a 4. So that takes care of this integral here. And then the integral of 1 with regards to theta multiplied by 9 over 2 is just 9 theta over 2. So now I've got 9 theta over 2. Okay, right. So that's where we are so far, which is looking good. So now I'm going to take this off the board, bring this up to the top, and then continue to solve these integrals. Okay, right. So I've got 9 over 4 sinh 2 theta plus 9 theta over 2. So now it's all about trying to get my theta value plugged in here. So if x equals 3 sinh theta equals x over 3. So therefore to get theta on its own, I've got theta equals inverse sinh function of x over 3. Okay, so that's good. So now I've got a theta value. So now I can plug them into these and see what we can do to progress from there. So 9 over 4 sinh of 2 theta. So now I've got sinh of 2 of this inverse sinh function. Okay, so that's all of that. So that's looking a little bit messy there, but we got a trig identity that can take care of that. And then 9 theta, I've just got 9 of this divided by 2. So now I've got 9 sinh minus 1 of x over 3, all divided by 2. So I can just leave that in there. Now I'm not ready to just put my plus c in there and declare this as my answer. I want to get this back in terms of x. So this one, I know what this one is. We can do the log identity for the inverse sinh function. So sinh of x, we know that this is the natural log of x plus square root x squared plus 1. So if I've got sinh of x over 3, where I see an x, I just plug x over 3. So I can take care of that. So now I've got 9 over 4 sinh of 2 times this logarithm, but with x over 3 as my input. So 2 times the natural log of the absolute value of x over 3 plus square root of x squared over 9 plus 1. So that takes care of all of that. So I'm going to stick that in a bracket. And then here, plus 9 over 2. And then my inverse sinh for x over 3 is the same as what I've got here for my input. So I've got the log of x over 3 plus square root of x squared over 9 plus 1. Okay, right, let's just take that little bit of my trig identity off there just to give me a little bit of space. Okay, now let's see if we can simplify this off even more. So this one here, what I could do is my square root. So if I've got square root of x squared over 9 plus 1, what I can do is, if I take the square root of 9, which is in the reciprocal, so square root of 1 over 9, that would just become 1/3 times the square root of x squared, as I've taken that out, and then all I have to do now is plug in a 9. So these would then become the same value. So I can do that for both of these. So now I've got 9 over 4 sinh of 2 times the natural log. X over 3 can stay, and that will go there like that. and then plus 1/3 square root of x squared plus 9, that's all absolute value, and then plus 9 over 2 natural log. Again, same input for here. So now I've got x over 3 plus 1/3 square root x squared plus 9. Okay, now this one here, if you do the algebra on this, what you'll get for this is like this. You'll get 9 over 4, and then this, all of this here will be in terms of x. So we have to get rid of this sinh function, remember, because we don't want that in our result. We get for that 2x over 3, and then we've got square root of our x squared plus 9, and then the 1/3 will come out as well. So that will be then 2x over 9. So I can change that to 2x over 9. And then these are all multiplied together. So that just becomes that. And then this one here, that will just stay as it is. So plus 9 over 2 natural log x over 3 plus 1/3 square root of x squared plus 9. And now we just need to just simplify it off and put in our plus c. So these two 9's will cancel. This 2 will cancel, and that will become a 2 there. So now we've got x over 2. So that will become x times the square root of x squared plus 9. So that can go like that, and that will all be over 2 plus 9 times the natural log. Now here I could factor out 1/3, so let's do that. So I've got 1/3, and then I've got x, so that will be factored out with that one, and then this one I need the square root. Okay, that one takes care of that, and I need to divide it all by 2. And then all I need now is my plus c. So I can just squeeze that in the end there, and then that will give me the answer to my integral, my third way, where I use the product to sum formula to get to my answer. And then this one, our integral, gave us that result. Okay.